efficiency is a mathematical concept, but don't be scared. It's just a simple division problem. Efficiency is a ratio. And a ratio means a fraction, one thing divided by something else, or one thing compared to another thing. Efficiency is a ratio of what you get out of a machine, we call that the output, to what you put into a machine. And not surprisingly, we call that the input. The units we use for output and input are both joules. That's how we measure energy. So let me clean this up. I wrote this big sentence here. As a fraction, as an equation, it's like this: efficiency equals output over input. And that's it. Now, if you solve this, you're going to get a decimal for an answer. And a lot of people, for some reason, don't want to hear a decimal as an answer. So if we want to hear this as a percent, what we do is we multiply this right side by 100, and that turns our efficiency into a percent. So let me write this one more time then. So efficiency equals, I'm going to write the 100 on top here. So out times 100 over input. This equation right here will solve 3 of the problems on the efficiency quiz. So let's just do an example. Let's say that we've got a person standing next to a flight of stairs, and let's say that to get up that flight of stairs it takes let's say it takes 100 joules to get up to the top of the flight of stairs. So let's say this person goes out and they have themselves a bowl of cereal, and that bowl of cereal has 100 joules. So if you take that 100 joules worth of cereal and you eat it, and now it is in you, you have that 100 joules worth of cereal in it, you go over to the stairs and you think, should you be able to get all the way to the top? You might think you should be able to do that, or you could do that, but the answer is, unfortunately, no. You could only go up about 10 joules worth of stairs. So that doesn't sound right, does it? You take in 100 joules and you get to use 10 of it? Well, that's because we humans aren't that efficiency. We humans aren't that efficient. We don't get to use all of the energy that we take in. We are only about, let's solve that. Efficiency is our output. We got up 10 joules worth of the stairs. Here's my 100, so 100 there. And we put in 100 joules worth of cereal. So 10 times 100 is 1,000. 1,000 divided by 100 is 10. And that's percent, because that's what this 100 did for us. So we humans are about 10% efficient. Seems kind of wasteful, huh? One more really quick example. Like if you have a car and you have some gasoline, let's say that you have, I don't know, 20,000 joules worth of gasoline, and you're going to put that whole 20,000 joules worth of gasoline in the car, and then you're going to see what that can get you motion-wise. Actually, I'll tell you. Like, let's say that this car, you put in 20,000 joules worth of fuel, it goes about 5,000 joules worth of motion energy. That's what you can get out of it. So let's figure out the efficiency of the car. So the efficiency is going to be the output. The output in this case is the 5,000 joules. I don't know if it matters if you write that, the J in there, times 100 divided by 20,000 joules. And the joules just cancel, so I don't often even bother to write them. But so what we've got here is 5,000 times 100 divided by our 20,000. And now let's cancel out some zeros here. There's 1, 2, 3, 4. 50 divided by 2. Okay, so 25%. So that car is 25% efficient, and that's actually pretty accurate to a car's efficiencies these days. So I thought about in this video going into, well, what if I give you the efficiency and I give you the output and I ask you to get the input? Could you do that? Well, you've already passed manipulating an equation, so that's something you should be able to do already. Maybe I'll make a separate video and solve a couple of efficiency questions about that. So next I want to talk about some efficiencies. So I went out and I found this image, and let's see, a lot of our energy, a lot of our electricity that we use comes from burning coal. And unfortunately, you know, it's dirty and we have to dig up the earth and it looks all nasty and then there's runoff and pollution and stuff. But I was curious about how efficient those things are. And right here, coal and oil, this is how we get a lot of our energy. And they are in the neighborhood of 40-something% efficient. So what are some better choices? Well, what about hydroelectric? They're right at the top here. I mean, 90-something% efficient. Well, that would be nice if we all lived someplace where we had a big elevation change and we all had big rivers that we could dam up, but then that leads to other problems. When you dam up rivers, you get other ecological issues. You know, you don't get the fish that you used to have, and all the critters that depended on that ecosystem are gone. Some people talk about radioactive, like using fission right here, using uranium and stuff to boil water to get our electricity. But the problem there is, you know, the waste, the nuclear waste is dangerous for thousands and thousands of years. So, you know, there are people who are against that. And besides that, I mean, just look at this. You know, if you want to dig up uranium, what do you got to do? You got to make a giant hole in the ground, and then that's just a kind of an environmental nightmare. So one solution that I hear people talking a lot about is, rather than focus entirely on different fuel types, what if we tried to make better use of what we're using now? So look at this. I found this graph. And when I was a kid, the only light bulbs that we had in the house were these kind, incandescent bulbs. They had, you know, the little light bulb filament in there, and it gets all hot and glows. And there's halogen bulbs now, and there's compact fluorescents and fluorescent tubes, and now you can go out and buy LEDs. But take a look at this. This graph shows what it takes for these other types to give off the same light as a 100-watt incandescent bulb. So if you wanted to have 100 watts worth of light like this, you could get it from an LED at less than 20 watts. So that means this LED bulb right here is more than 5 times efficient. So if everybody in the country got rid of all these and switched to these, then they would use more than 5 times less. That's a terrible sentence, but they'd use better than 5 times less the energy to light their homes and businesses and stuff. But the problem is, how much does an incandescent light bulb cost? You know, it's just probably less than $1, and these things are still you know, more expensive, but they're coming down all the time. So anyway, that's my video on efficiency, and away I go.